All right, so in this lesson, 12.9, we are actually going to start talking about three-dimensional figures and then solving and really solving the volume of them. Now, volume is similar to area in that we are multiplying our measurements. However, we are finding the space and the capacity of those three-dimensional figures. So area, we talked about that being our base times height, and those are two-dimensional figures. Well, volume is going to be when we take the length times the width times the height, and we have three dimensions. So that's why we have 3D figures. So let's break down some of our definitions. So volume is the amount of space inside a three-dimensional figure. You can either use the formula below, length times width times height, to find the volume, and V volume, L length, W width, H height, or you could say it's big B equals length times width, and then take that times the height. Now, I'm going to be using the volume equals LWH more often, but the big B is meaning the area of the base. And we call our three-dimensional figures their name based on what the base shape is. So if the rectangular prism, the base of it is a rectangle, whereas a triangular prism, the base of it is a triangle. Either way, we find the area of the base and then we multiply it by the height. Anyways, so common units in volume are cubic inches, cubic feet, cubic yards, cubic centimeters, cubic meters. I hope you find the pattern there that we have cubic as being the common word and that we talked about length times width times height. So if this was meters, meters, and meters, well, that is meters cubed, and that's why we have cubic meters. All right. So let's do a quick side explanation of this big base times height versus length times width times height. So if I were to have let's draw this out real quick. So if I were to have a rectangular prism here, and let's draw this where we have a prism, and oh goodness, we can do better than that, right? And so that's slightly better. I'll do better the next time, right? That if we were to have let's have this as 2 inches, and this is 3 inches, and then this is 5 inches, right? So to say we are going to find the area of the base, I'm saying I'm finding the area of the base down here. So that would be like saying the area is base times height. And so I would say, well, that's 2 times 3. And so the area of the base would be 6 inches squared. Now we are going to add in this third dimension, and that is our height of the entire thing. So that's why we use length times width times height, because if I didn't, and I said, well, this is going to be base times height, well, this gets really confusing to say, well, I'm going to have the height squared. That doesn't, well, no, this doesn't, we don't do that, right? That just gets confusing. So that's why we use length times width times height. Now, if I have my length as 2, my width as 3, and the height of the three-dimensional figure is 5, well, I can simply do my triangle math. 2 times 3 is 6, bring down my 5, 6 times 5 is 30, so this would be 30 inches cubed, and that would be the area, or that would be the volume of the entire thing. Because think about this, if I had this as this was 1 inch up, right? If that was 1 inch, what I have just shaded in here, well, this would be 6 inches cubed. But now, since I'm going to keep on doing this, that's 2, 3, 4, and 5 up here. Each level that I am, coming in here, this is just another 6 inches. And so if I layer this is why when I multiply, the height, it's like adding each one of those layers up, and I keep on multiplying the area of the base times the height, and that gives me the entire volume. Let's look at some examples here. So, on his family vacation to the beach, Armando filled a cooler with water and snacks. Find the volume of the cooler. Very realistic, real world kind of thing. So the volume is our length times width times height. So the length of this we're going to use as 30, and our height, or I'm sorry, our width is going to be 15. Because if I were to break this down and say, well, I have a cooler right here, right? If I were finding the area of this on the inside, right? This, if I just were looking at the bottom space of our cooler, that would be this bottom section. So that'd be like saying, well, I'm going to multiply 15 times 30. So 15 times 30. 0 is that first in the ones place. So I'm going to skip it. And essentially, I'm using that placeholder 0 concept. And 3 times 5 is 15. Carry the 1. 3 and 1 is 3. Plus 1 is 4. So that is 450 just for the area of the base. That's why that's big B, right? Now, since I'm going to do this the other way, I have the height, right? So 30 times 15 times 20. I still need to multiply them just one at a time. You can't like layer your multiplication. So I'm going to take 450 times 20. Again, I'm going to have this place. I'm going to simply put a 0 in here because 0 times everything is 0. So 2 and 0 is 0, 2 and 5 is 10, carry the 1, 4 and 2 is 8, plus 1 is 9. So the area, I'm sorry, goodness, the volume of this entire cooler is 9,000 inches cubed, right? Now, if we did this the other way and did big base times height, well, again, I have to multiply the length and the width, my 30 times 15, to still get 450. And then I'm going to take 450 times 20. See, you're still doing everything the same by saying length times width times height. That's why it's always just simple, is keep one formula that makes a whole lot of sense and just say volume equals length times width times height. And know that that is going to be whatever unit it is cubed. All right, let's do another example here down. All right, so find the volume of our prism. So the length times width times height. The way that they order these, I can see that my length is going to be 17, my width is 7, and my height is 9. Now, it doesn't matter the order that I multiply them in, all right? I can change up the order as much as I need. So my volume is going to be 17 times 7 times 9. I don't have to go 17 times 9 first. I can do some math that I know. So the associative property here is I can multiply 9 times 7. That's a whole lot easier to work with, and say 63. Now I can multiply that by 17. And again, do your work on the side. So I'm going to say 63 times 17. 7 and 3 is 21. 1 down, carry the 2. 7 and 6 is 42. Plus the 2 is 44. Now I'm going to use my placeholder 0. And I continue on and say, well, 1 and 3 is 3, 1 and 6 is 6. I add 1 and 0, 1, 4 and 3 is 7, 4 and 6 is 10. So I have a total volume of 1,071. And I look at my labeling here. So this would be centimeters cubed. So 1,071 centimeters cubed. Find the volume of each prism here. So if I were looking at this, I have my area of my base, right? I'd say, well, 11 and 7 is 77. So I could do this different ways. Choose your own adventure. And here I can mentally look at this. And so I could say, well, that's 77 times 9. I then can just get rid of this other part here. It's what makes sense to you. This example, I'm using big base times the height. to give my volume. Because mentally, I can just look at this and say 11 times 7 is 77. So now on the side, I simply do 77 times 9. 7 and 9 is 63. 3 down, carry the 6. 9 and 7, 63. Plus 6 is 69. So I have 693 millimeters cubed. If I look at our next one here, I can look at this and say, well, they already gave us the big base. So again, volume equals big base times height. And so they said, well, 24. Well, that makes sense because 4 and 6 is 24. And so 24 times 12. Again, I have to show my work. 24 and 12 multiply. 4 and 2 is 8. 2 and 2 is 4. Placeholder 0. Always make sure that you identify that. 1 and 4 is 4. 1 and 2 is 2. I add 8 and 0 is 8. 4 and 4 is 8 and 2. So the volume of this is 288 feet cubed. Don't forget that this is still cubed. If I didn't do this as big base times height, and I said 4 times 6 times 12, well, 4 and 6 again is 24. But if I did this differently, if I said I wanted to go about this another way, I could multiply the 4 and 12 and say, well, that's 48 times 6. Will I get the same answer? Let's find out. Well, 48 times 6. 6 and 8 is 48. 8 down, carry the 4. 4 and 6 is 24. Plus 4 is 28. Again, I get the same thing I did before, which makes sense, and hopefully everything like that works out. All right, so that is our notes on finding the area of, finding the volume of prisms. Hopefully that last bit of same area, we are finding the volume of prisms. We are finding the space inside a three-dimensional figure. Let me know if you have any questions.